In this video, we're going to be talking about the trig derivatives, the exponential derivatives, and also the inverse trig function derivatives. So to start off, the derivative of sine of x is equal to cosine of x. You simply have to memorize that. The derivative of cosine of x is equal to negative sine of x, and the derivative of tangent of x is equal to secant squared of x. Now you can treat tangent as sine of x over cosine of x, and then you can use quotient rule on this as well in order to solve for the derivative of tangent of x. So quotient rule once you do quotient rule of sine of x over cosine of x and find the derivative of this function, you have found the derivative of tangent, and eventually you should end up at secant squared of x. With the other ones, cosecant of x is equal to negative cotangent of x cosecant of x. And again, cosecant of x is equal to 1 over sine of x, so you can do quotient rule on this as well in order to derive negative cotangent x cosecant x. So the derivative of secant is equal to tangent x secant x. And the derivative of cotangent is equal to negative cosecant x. So with the secant, you can use quotient rule on 1 over cosine, and with the cotangent, you can use quotient rule on cosine over sine. So really, the only trig derivatives you need to memorize are sine and cosine. The rest, you can just use quotient rule to find their derivative using your memorized derivatives of sine and cosine. Let's move on to some inverse trig derivatives. So now we're on to inverse trig derivatives. The derivative of arc sine of x is equal to 1 over, let's fix this x, equal to 1 over the square root of 1 minus x squared. Now keep in mind, if you had a function other than x in here, then you would use chain rule to solve this problem. But the derivative of arc cosine of x is equal to just negative 1 over the square root of 1 minus x squared. And then the derivative of arc tangent or inverse tangent is equal to 1 over 1 plus x squared. So chain rule applies in all of these if you have some function other than just x inside of this. Now, on a side note, if you're taking an AP calculus class, when I was taking it, the arc sine, the arc tangent ones were the most important. We didn't use any other of the inverse trig derivatives. But the derivative of arc cosecant x is equal to negative 1 over the absolute value of x square root of x squared minus 1. Now these aren't as necessary, but you definitely have to memorize these if your teacher specifies, maybe if you're taking a college calculus class, but AP calculus doesn't really care about these ones. The derivative of arc secant is 1 over the absolute value of x squared of x squared minus 1. So the derivative of cosecant and secant, just differences, is 1 negative. And then the derivative of arc cotangent x is equal to negative 1 over 1 plus x squared. So it's just the negative of arc tangent. So now we're on to exponential derivatives. The easiest one to memorize is the derivative of e to the x. Hopefully you already know this. Maybe your teacher just brought it up, but the derivative of e to the x is simply e to the x. The derivative of some number to the power of x, though, a, is different. The derivative of a, or maybe 2x, right? A can be any number, is ln of the natural log of 2 times itself, 2 to the power of x. No, actually, well, this is the example, but it would be ln of, the general formula would be ln of a times a to the power of x. The derivative of log a of x is equal to 1 over x ln times the natural log of a. Now, keep in mind, This one is not as prominent in AP Calculus, but these ones are quite helpful, especially the e to the x one. And also, chain rule still applies for all of these. So although I have an x here, technically this x represents some general function. So it should be u as the right notation, but again, your chain rule matters. Okay? Your chain rule matters when you're solving these. So another one that's quite easy to remember is the derivative of ln of x. So the natural logarithm x. A natural logarithm, if you don't know, is just same thing as log, but the base is e. So the base is specifically e, and that equals the natural logarithm. The natural logarithm is 1 over x. This guy is quite helpful. And then lastly, we have something special. The derivative the derivative of e times a to the x, or n to the x. So any number, so maybe e to the power of 2x could be an example of this, is equal to n times e to the nx. So as always, if you have any questions, put it down in the comment section. And if you found this video helpful, consider subscribing and liking the video. Thanks for watching.